Thank you very much, everybody. And I'm looking forward to presenting what is a team effort here from ParallelWorks and initial results using parsl-perf to evaluate performance in a hybrid HPC environment. So a little bit of motivation and context. ParallelWorks provides a high-performance computing control plane where you can connect various resources, on-premise clusters, cloud resources, cloud clusters that have been provisioned through infrastructure as code. So that's referring. So when Patrick mentioned earlier infrastructure of code, we use infrastructure as code. We use that as a mechanism for deploying like SLURM clusters in the cloud, and we place them side by side with your on-premise clusters. And one of the key things that we'd like to do is to help our users understand the kind of cost performance landscape across the many different resources that are all being connected to the single control plane. And eventually, this kind of work of being able to deploy like benchmarking across different resources would be helpful for informing smart scheduling. So similar to the kind of stuff that Alok was mentioning earlier today about like how to place jobs in the best possible places given those different resources. And but for now, I'm not going to get into smart scheduling now, but for now, what we're doing is we're aiming to automate a suite of tools for benchmarking, and one of those is parsl-perf. And so I just discovered parsl-perf recently, and I think it's absolutely wonderful. The idea is you can give it a parsl configuration, and when you run it, it will then attempt to submit as many tasks as it possibly can over a given time window. And so this gives you an idea for basically how many tasks per second you can submit to your local provider, to a SLURM cluster, to a Kubernetes cluster. And all you have to do is change out the parsl configuration, so from one configuration to the next. And so this is great from a hybrid computing perspective because you can do it from one resource to the next. But the problem is, how do you keep track of parsl-perf runs across so many places at once, across all these different clusters? And so what we built here is a framework for keeping track of things. So I wrote it out kind of in pseudocode. So for each of your different high-performance computing resources, whether that's your laptop or your cloud cluster or your on-premise machine, I created a GitHub repository that has an archive of parsl performance runs, but also it has an install script that will basically install parsl and all the things you'll need for it. So it's kind of like environment as code, right? And then we're using MLflow as a way to store and manage and visualize. And so I'll show you some examples of that in just a moment. So basically the idea is you grab this GitHub repository, you start an MLflow server, and then you say, okay, I want to experiment with different parsl configurations on this resource. And so you start a loop, right? For each parsl configuration, you launch this wrapper, which will gather the information inside that parsl configuration. So things like CPUs per node, right? Or the maximum number of blocks, right? Those are all the input parameters to running parsl-perf. And then it will actually kick off a run with parsl-perf with that parsl configuration. And then it'll gather the output of that run as metrics, right? So, and it'll take, so that the output of parsl-perf in this case would be the number of tasks per second. And then the idea is to then take all that information, the parameters, which are the inputs, which are coming from the parsl configuration, and the outputs, which are those tasks per second, and push it all up into MLflow. And MLflow is great because it'll store all this information as separate tiny little files. And if you're doing this in multiple places, you can all merge it to the same GitHub repository and avoid merge conflicts because you're not working on the same file. So here's some example screenshots of what it would look like. Oh, and the idea is you can put other applications, not just parsl-perf, but you could put other benchmarking applications or other large applications in the middle of this loop. So here's an example of an MLflow instance that has a bunch of runs on it on the left-hand side, and then it's visualizing some of these metrics. Here at TPS is tasks per second that are being launched on each of these instances. And because I'm setting up I'm bringing information from the parsl configuration into MLflow and importing it, I have explicitly added things like the parsl provider, the parsl version, and you can then group your runs based on this information that's coming directly from the parsl configuration that was used to run parsl-perf. So for example, if I group runs that I made recently by their parsl provider here, it will then show me the runtime of the tasks per second associated with each of these providers. And so in this case, I'm running on a 16-core cloud head node it's a head node of a SLURM cluster. And so I can run a bunch of jobs locally to it through the local provider. And so I might get like a little more than 800 tasks per second being submitted on that. I can start a Kubernetes cluster on that node, and I can submit jobs into that Kubernetes cluster. And then I can also submit jobs to the SLURM cluster, the SLURM workers that are behind that head node. And I get more tasks per second. I'll get a little over 1,000 tasks per second as I'm submitting jobs to that SLURM cluster. And then you can also grab all this output and you can save it as a CSV file. Here I just did a really quick plot showing tasks per second versus the number of blocks. But the key point is that you can grab the output and do more detailed analysis. You're not constrained to whatever plotting is available within MLflow. And so some next steps are to systematically test this with bigger and bigger clusters over many different cloud service providers. I'd like to expand the library of parsl configurations, provide some templates for local Kubernetes clusters or local containerized SLURM clusters, and also encourage folks that if you're interested to engage and fork this repository, make some runs, you can contribute your runtimes back through a PR. In particular, just getting an idea for a wider variety of compute resources, what their tasks per second are, and also figuring out what works and what doesn't, and what are the best parameters and metrics to be stored. So thank you very much.